So, when I expirate, when I breathe outward, that is really just the diaphragm relaxing and moving back into its normal position, right? Normally, expiration is not a forced something, right? It's just the result of the diaphragm relaxing. But if I want to forcefully exhale some air, what works then? How does that work? Somebody give me some thoughts? Try it. Put your candle up and forcefully blow it out. What do you feel working? Okay, your diaphragm has to make a kind of a quick up movement, though that's kind of relaxing, right? When it contracts, it moves downward. Abdominals tighten, right? What else? Your other intercostal muscles. You've got two sets of intercostals that run opposite directions. And they also help that contracting here. Are you with me? Okay, so normally, again, expiration is just relaxing. But you can forcefully do both and pull in other muscles. We talked a little bit about this yesterday. So let's spend some time back again breathing, okay? And again, I realize, Andrew, as soon as I say this, everyone starts breathing differently, right? But just breathe normally for a moment. I just want you to get a feel. Again, pay close attention to how are your shoulders moving, is your chest moving, is your stomach moving? Not talking, just breathing. Don't be distracted by other things, just breathing. And so what you are doing right now, just this little breathing in, breathing out, is what we call your tidal volume. Like a tide, right? That just keeps coming in, going out, coming in, going out, right? And that's pretty small, right? The numbers that are on your sheet, about 500 milliliters. So a 2-liter bottle of soda, right? A fourth of that is your normal in and out. Not very much air, right? Now, obviously, that changes based upon how big or how small you are, because your lungs usually are very correlated to how big of a person you are. But that's just your tidal volume. We don't breathe a whole lot. Okay, so here's what I want to try and do. See if we can't explore the ranges here like we did a bit yesterday, but in a little more detail. So I want you just to take a normal breath in. Just, again, don't try and, but just a normal breath in, and hold it for a second. And then breathe it back out. Just a normal breath in, we'll hold, and then back out. Once you take that normal breath in and you pause, can you breathe in any more? There's still a whole lot left, right? And you can just let it come out back to your normal spot. So that would be your inspiratory reserve volume, right? And again, if you're looking at, well, I didn't put that on your sheet here, but you're talking a good couple thousand milliliters, right? 2,400 or so. That you've got a large capacity that you can still breathe in, right? Think about when you go to go dive into a pool, right? Or go down to get something from the bottom of a pool, right? You're taking a big breath in, right? Okay. So let's do the same thing again. I want you to take your normal breath in and pause. And then a big breath in. And then just back to normal. You with me? That same. So little breath in. Pause. Big breath all the way in. And then, and you're back to your normal spot. Right? Before I get your question. I want you to try this one more time, but when you get to your bottom spot, I want to see, can you keep pushing out any more air? So we breathe in normally, big breath in, back to our normal spot, but there's still some more air left in there that you can try and get out. That would be your expiratory reserve volume. You notice that's pretty low, right? Not too much there. About 1,000, 800, 900. Are you with me? So you have this whole huge range that based upon what you're doing. Now, if you're exercising a lot and you're running, you're going to use a much larger tidal volume, right? You're going to not just breathe this small little breaths. You're going to take big breaths and forcefully exhale, right? In order to get more oxygen to your muscles to work, right? Your question.
So if the tidal volume, if that's just sitting in your lungs, that doesn't have much oxygen, right?
So this is not sitting. Each time this is going in, going out, going in, going out. So no, you are just consistently breathing in and out.
Well, isn't there like some air that's not going out when you do that?
Sure, yeah.
So does that air have like less oxygen in it because it's already been pulled out?
It has some less, but we have still, when you breathe out, you still breathe out oodles of oxygen. So even if I were to shut you off for a couple of minutes, you can still live on the oxygen that's in the air in your lungs. So does that make sense?
So if you're like diving, would it be better to like breathe out as hard as you can and then breathe in? Because then you get like...
It's okay, sure. You're kind of trying to refresh everything. Sure. Yeah, I'm good with that. The amount of oxygen you're talking about is not a ton, so it's not going to make too much of a difference, but I hear where you're going with it. Yeah. Yeah, yawning is a difficult piece. I have not seen any research that will tell you exactly why. They think it's mostly this psychological piece. Even just us talking about yawning is making a bunch of you yawn right now, right?
But you could say yawn in a different language.
True, very true, right? So some folks think it's because you have like a drop in the oxygen level, and so it triggers this, let's yawn. I don't really know. I'm not sure that there's an honest answer for what causes it yet.
For the second question, how come, like, at least for me, when I concentrate, I catch myself, like, and not thinking. So why is there moments when
I guess your focus is just on that so intently that you forget to breathe. Breathing is something that will continually just happen, but sometimes in those intense concentration moments, yeah, you're so focused that your body is just. Now you will not like you will die from that, right? You will eventually breathe because your body says, "Hello, I need oxygen." Yeah, but no, that's not uncommon. Yeah.
How come, like, when you get hiccups, like...
So a hiccup is just a spasm of your diaphragm.
Because you, like, swallowed air?
Yeah, it can be because of that. There's a number of things that cause those kind of pieces. But yeah, it's just this rhythmic contraction that usually for most of us goes away fairly quickly. There are people who go years with hiccups. Yeah. Oh yeah, no, not at all. Yeah, it would not be very fun. Just continuously hic, Mm-hmm. It's tough, right? I mean, you can still eat, but no, right? It would be tough. Yeah. No, hiccups are no fun until they won't go away. Yeah, please.
So how do you, like, train yourself to hold your breath for a long time?
Right. You can increase the capacity of your lungs by continually working. It's like any other type of muscle. You can get yourself where you can get more of that, use more of that reserve. Now we all have a limit, right? Because you like literally have a certain only amount of space your lungs can hold. But it's also training your body how to use the oxygen slower. Like these divers who just free dive and go down for 5, 6, 7 minutes, they're almost in this like trance-like state where they're just using very little oxygen. All their other body things kind of shut down.
How do you train your body?
I guess you just keep doing it. Yeah, yeah.
Eventually your body will be like, oh, that's what you want.
Right. Again, they focus on slowing their heart rate way down, calming their breathing, very little motion that's not needed, just kind of shutting down all the things you consciously can do. And yeah, I can't do it, so I don't know exactly how they do it. But yeah.
How do you swallow air?
How do you swallow air? Just like you swallow anything else.
So if I just like swallow air.
Yeah, I mean, some people can like purposely do that to like cause themselves to belch on purpose. Yeah.
Oh, like that?
Yeah. Because that's all a belch is, right? A belch is just air is in your stomach that you're getting back out. Okay. We're good there. So again, that total lung capacity, the total amount your lungs can hold is about 3 2-liter bottles, right? About 6,000 milliliters. But we only deal with that vital capacity is only about 2.5, well, 2.25, right? About 4,500 milliliters is this amount that we deal with consistently. You have that leftover that we just can't get at. All right. There's a couple of pieces that they talked about and we've already talked about a number of them here. These non-respiratory movements. I don't think that I have a slide that talks about this. I don't. Stay with me, guys. Yeah, we don't have a slide that talks about this. But there is a nice box. Hey, guys. Like, I've let you sit where you... I've noticed how many of you have moved, okay? But I need you not to talk then. Are we cool? I can go back to treating you like first graders and put you in seating charts, but you're seniors, right? I appreciate that. On page 465, there is a nice box that talks about some of these non-respiratory movements, right? So we've already talked about some of them, like yawning and hiccuping, right? But there's also coughing, right? So coughing is forcing air upward, right? And what that does is usually trying to get rid of something from the lungs, right? It's a very forceful something. Again, some of you have been sick and you've just been coughing over and over again for days and days and days. Have you ever gotten sore from coughing? Like stomach and, it just terrible, right? Now, I'm not talking about throat being sore. I'm talking about like literally the muscles that make you cough. They can hurt if you've been doing it so often. And a sneeze is basically a cough, but in your upper respiratory system. Are you with me? So something is causing an irritation in your nasal passages, in your nasal concave, back in the nasopharynx. And to get rid of that, it triggers this reflex of sneezing. And we all have, it's always interesting to hear the various sounds people make when they sneeze. From these little tiny, you know, to my father, it like explodes like, like you can hear him probably all the way here from our house, you know. He was sneezing last night, and I was like, whoa, man, whoa. Felt bad for my mom right next to him.
How detailed do you want us to know about this? Because, do you want us to know like exactly how because it'll tell you like for the coughing, it talks about the glot, closing the glottis, pushing it upward.
Again, it will just be that forceful upward pressure. Okay. That's you're forcefully expelling something from the lungs. Air first, of course, but then usually some sort of mucus or some sort of something that's lodged there. The Heimlich maneuver, are you comfortable? That is just simply you coughing for that person. Like you are smashing air up against whatever is caught in their throat, and the goal is to try and get that thing to pop out. Question?
So if you hold your sneezes, what are like the...
I'm not sure physically you can. Like you can stifle them, but it's a reflex that I'm not sure we can actually voluntarily stop. Does that make sense?
Like it happens, but like you try to contain it. Like it's just a habit of yours to like not...
Yeah, I mean you are by stifling it, you're kind of trying to go against the reflex, right? It's trying to make this big forceful push out of air, and you're trying to calm that down, you know? So I'm not sure you're going to do damage per se, but I don't think there's a way you can stop it. I think once that reflex has been triggered, it's going to go. There are a number of different causes. It's a spasm of that diaphragm. What exactly causes it? There's a whole bunch of pieces. I don't think that they can say, boom, if I do this, I give you hiccups. Excuse me. I don't have a good solid answer to give you as far as that one goes. Does anybody else sneeze when they look at a bright light or the sun? Yeah, it's a fairly rare thing. Yeah, some of you are like, what? No, if I need to sneeze, I will look at a bright light. These are not quite bright enough. But if I look at the sun, almost consistently I will sneeze. My daughter the same way. And it's a hereditary thing. Yeah, it's because of the stimulation of that optic nerve from your eyes going back is right near the same place that controls the sneezes. And so by having that stimulation, for us at least, it causes that. Oh no, I did too. Until my wife's like, wait, what? You sneeze, look. No, yeah, don't you? No. It's pretty rare. It's actually, I think, about 20% of the population. No, it's just unique, just special. That's all.
My dad would be like, "Go look at the sun."
Yeah, right. Sir. I can't see. What? Well, not for significant periods of time, but yes. We covered that in the eclipse, right? There was this tweet somebody wrote that just cracked me up. They're like, around the eclipse time, they're like, I didn't realize we had to specify so clearly, don't look directly at the sun for long. Doesn't that just kind of make sense? Anyway, just made me laugh. All right, let's keep rolling. Let's keep rolling. Let's talk about control of breathing. So, are you comfortable that normally breathing is just involuntary, right? You are just breathing along here for the most part without having to think about it, right? You're just doing it. But we can then take and remake that breathing voluntary, right? We can choose to say, hey, I'm going to hold my breath. Or, hey, I'm going to take a big, deep breath in. Or, I'm going to blow in somebody's ear. Expirate, right? We can control those pieces. So it's both voluntary and involuntary. So there are a group of neurons in the brainstem that we call the respiratory center that controls breathing and adjusts how you are dealing with it. Now remember, brainstem controls what kind of actions? Let me rephrase. Is brainstem something that controls things that you consciously think about? No. This is the autonomic area, right? Some folks call it your lower brain, your animal brain, right? That you're not actually thinking, it's just you're breathing, right? So that's where most of that control comes from, right? And from the medulla, from the pons. Do you remember these places in the brain? Right? These are the areas in that brainstem that control your breathing. Then up in the medulla, you have two groups of neurons that help do this control. The dorsal, remember dorsal means posterior, right? And the ventral. Ventral means anterior, right? So the dorsal group is responsible for that basic rhythm, just that tidal volume, in and out. Making sure you breathe in. And it's normally about 8 to 10 times a minute. That's how often you breathe. Just depends on how active you are or what you're doing. It's not a very rapid kind of thing. The ventral side, so again, the anterior side, is active when more forceful breathing is required. And again, in that pneumotaxic area, that's where you control the rate of the breathing. So here's the view of the neurons coming down. So we're talking about the dorsal and ventral group there in the medulla, right? Remember, medulla oblongata, then the pons up here and the midbrain up top. Those three pieces of the brainstem. So there is the pons group, the pontine respiratory group, so the respiratory piece in the pons. But most of that piece is happening down there in the medulla oblongata, both the ventral and the dorsal pieces. And you see then they are sending these signals down into the muscles that control both the diaphragm and the internal and external respiratory. The external intercostals are for breathing in. The internal are for breathing out. It seems a little opposite, but that's one way you can remember it. The internals for breathing out, externals for breathing in. Yes. External in, internal out. Are you with me there, my friends? And so again, nice, fairly straightforward question, talking about the pieces of the brainstem that play a role. So are you comfortable if you had damage in that part of your brainstem? Would that be a problem? Why? Are you comfortable there's very few things you actually have to do to stay alive, but breathing is one of them? Right? You've got to keep your heart pumping. You've got to bring oxygen in and out. I would say those are like your two basic requirements for life. Okay, that doesn't mean you need to think and do all the other pieces, right? But if you aren't getting consistent breathing in, that is a problem, right? Okay.
Do some people live like having to consciously think about it all the time?
Boy, that's a great question. I don't know the answer to that. I know in my experience it seems like any kind of problem that can happen has happened somewhere. But I'm not sure how that would work. If you were not, I'm assuming they would be on a ventilator if you couldn't consciously or unconsciously control it. Yeah. Right, exactly. Yeah. Or even I'm doing something and oops, I forget to breathe. Yeah. So some pieces that affect, some factors that affect how often you breathe. So, chemicals, lung tissue stretching, and emotional state. Kind of your three pieces. So chemosensitive areas, so central chemoreceptors, are associated with the respiratory center in the brain and are sensitive to the blood carbon dioxide and hydrogen ions, the concentration of these guys. Carbon dioxide and hydrogen work together to make carbonic acid in your brain, or in your body, total. And this is one of the ways that your body pays attention to how much oxygen you have. You've heard of this term hyperventilating, right? Like that you've actually got too much oxygen, like you're going crazy, you're breathing too much. So what you do is you breathe into a paper bag, right? What this does is it helps increase the amount of carbon dioxide there, which will stabilize your breathing. Are you comfortable if you have too much carbon dioxide? That's another problem, right? So it's always that homeostasis, right? Not too much, not too little, just right. Very Goldilocks-ish, right? Okay? So, and here's what we say. If either carbon dioxide or hydrogen ion concentration rise, so if I've got too much carbon dioxide, I'm going to send the signal to the muscles to increase the rate you're breathing, to breathe faster, to do more, right? And obviously, if it was less, well, they're going to continue. The peripheral chemoreceptors in the carotid sinus, so right in your neck, right, where those carotid arteries are, and then in your aortic arch. Remember the arch coming off from the heart, heading down toward the abdomen? These guys also sense the changes in that blood oxygen concentration. And they, again, are transmitting impulses to that respiratory center and will affect, hey, I'm not breathing very deeply, so let's yawn and increase the amount of air I get and increase my oxygen level, right? That's one of the things they think as far as yawning goes. I'm sitting here in class almost falling asleep. Whew, let me move around and try and get myself some energy, get increased oxygen levels to give myself a little more arousal. The centers in your brain to signal that, hey, we don't have enough oxygen in your blood, we need more. So therefore you'll start breathing deeper, start breathing faster.
How did you say that? Keratin?
Carotid. Yep, carotid. You also have what they call an inflation reflex, that when you stretch, so again, remember the pleura, the visceral pleura is that surrounding tissue around the lungs, right? When that stretches, right, it triggers what they call the inflation reflex. And what that does is it helps to prevent you from overinflating the lungs if I'm forcefully breathing. So again, someone is challenging you to see who can blow up a balloon the most in one big breath, right? Or you are forcefully trying to blow out a candle, or there's a fire going and you're trying to, right? Well, if you breathe in too much, are you comfortable you could actually damage those alveoli? Okay? Because again, they're just little tiny, very thin little sacs. And if we try and force too much air into it, right, it could pop, just like a balloon. Well, sure, that would be very painful. Yeah, I'm not sure that, again, this inflation reflex prevents you from going too far. That's the point behind it, right? As in it prevents that overinflation piece. I would imagine there'd be some scarring that would happen, and like you would lose some lung capacity. Yeah. Cystic fibrosis, tuberculosis, these are lung type of diseases that cause damage actually to the lung tissue itself. And yeah, so you would have less capacity to breathe. We talked about hyperventilation. That is one way that you lower the amount of carbon dioxide. Hyper means a lot, right? To hyperventilate means you're breathing rapidly. Has anybody ever hyperventilated? I'm just curious. Yeah, no, it happens. Right, yeah. Sure, this thought of I'm going to put more oxygen into my bloodstream, yeah, sure. And then stop breathing, and you'll have more there. I hear you.
Do we have to know how like inflation mechanics work, or do we just know what it does?
Well, I mean, in order to understand how it works, I think you have to know what it does. I think that those two things go together. I think you should be comfortable that it is a stretch reflex from that pleura.
What does that mean, stretch?
As the tissue is stretched, to keep it from stretching too far. Like if you pull a rubber band too far, it'll break, right? Once it gets stretched far enough, it triggers that reflex to say, hey, don't stretch anymore. Contract the muscles so they won't let it stretch any further.
And what specifically are the stretch receptors? Just like tissue?
Yeah, they're nerves. They're neurons, yeah, that sense that mechanical change. They're mechanoreceptors. Okay, I think I don't think we have enough time to get through all the pieces here for alveolar gas exchange. So I think I'm going to stop right here. Can I tell you that for tomorrow, this is the piece that I really want you to be solid with, is this how the alveoli work. Because like I said, this is the key point behind the respiratory system. All of the tubes getting down, all that is just transport, right? The alveoli is what's actually doing the work in this system. So would you please make sure that you take a peek at that area for tomorrow. Of course, your questions are due tomorrow, right? So hopefully you've already gotten through that section piece. We do, yeah, there's this afternoon time. Yep, yep. No, we do something else. Yep, do something else. Are you with me, my friends? Any questions from where we've been going so far? I hope you found this to be fairly straightforward. I think this is a fairly straightforward chapter. Yes, sir? Right, so after looking at the schedule, and I appreciated those of you who gave me more detail about when you all will be gone, I did move it officially to the Monday after the week we get back. Does that make sense? I had said it was going to be the Friday, actually even the Thursday, because we're not here Friday. Shh. But I'm saying it'll be Monday. Now, if you really want to take that test on the Thursday before, come talk to me. Okay, because again, Friday we're not here. But if you don't want to have to deal with it over that long weekend, let's talk. I'm certainly willing to do that with you.
Long weekend. Do we have a... Oh, we do? For what?
It's Friday.
Oh, that's so cool.
Good. Other questions here? Yes, ma'am. The surfactant? Uh-huh.
Basically, you want us to know that the surfactant reduces the lungs or the alveoli and it will collapse, and then they might suffer from respiratory disease. I don't know.
Yeah, so again, in a baby, are you comfortable the baby is not breathing, right, guys? So therefore, the alveoli are collapsed, right? They're actually like stuck together because there's not any air in the lungs at all. So if I have two tissues that, again, are wet, they stick together. Like it's hard to pull them apart, right? So what the surfactant does is it lowers that surface tension of the water that's in between those guys so that when you take that first breath into your lungs, those alveoli open. And then you can actually exchange the gases there. If they stayed closed, air couldn't actually get into the sac, right? It would be like, I'm trying to find the good picture here. Well, again, imagine this is like a grape, right? If I squish that thing down, air can't get in, so there'd be no oxygen coming in. And so again, as a premature baby, surfactant is one of the later things that you develop in your developmental systems, in your respiratory system. So they have a synthetic that they can inject in there. Right, and of course, many babies that small will be on a ventilator because they aren't able to breathe consistently on their own. Yeah. It's an enzyme. Yeah.